Okay, we are on to day 2 on reflecting our graphs. Last lesson we discussed reflections that were across the x-axis, the y-axis, the origin, and the line y equals x. Today we're going to talk about some different types of reflections that involve the absolute value of a function. And so first of all, we're going to name the points again, just like we did in our last lesson. So remember that we're going to be using those points to make our transformations. It's very important that you name the endpoints, the points where the graph changes direction. And for today, the x and y intercepts are going to be very, very important. Last time you probably could have done without them, but not on this lesson. So to keep some continuity, we're just always going to use the x and y intercept as well. Now, I don't know if you realize it or not, but this is the same graph that was on our notes from our first lesson. And so we should already know what those values are, but this point over here is at negative 6, 7. And then we have negative 4, 1, negative 1, 4, 0, 3, 2, 0, 4, negative 3, and 8, negative 3. All right, so we're going to use those points, and I'm going to actually slide the original graph up and down so we can see them beside the example that we're working on. And so our first example says that they want us to graph the absolute value of that function. Now, I don't know if you remember what the absolute value means, but for example, if I just have the absolute value of negative 7, absolute value is always positive because it is a distance away from 0. So even if I go backwards 7 on the number line, I'm still going a distance of 7. The absolute value of positive 7, also 7. So absolute value basically means to make it positive. If it's negative, we make it positive. If it's positive, it stays positive because distance is always positive. And so what this is telling me is to take the absolute value of y. So in my y values in this chart, my y values right here, the only negative y values I have are the two at the bottom. And so we're going to make those y values positive. All the ones that are positive will stay as they are. So that's the only change we're making. The x's are going to stay the same. But this is going to be 7, 1, 4, 3, 0, positive 3, positive 3. All right, so if that's the only thing we change, then these 2 points should be the only 2 points that move. Everything else about this graph is going to look the same. So we're going to have negative 6, positive 7, negative 4, positive 1, negative 1, positive 4, 0, 3, 2, 0, and then we have 4, positive 3, and 8, positive 3. All right, and so when we get ready to connect those points, piece of paper here, start over here, connect in the order that we drew them. Now, like I said, the only thing that happened here was that this little section of the graph where the negative 3's were reflected up above. So if we're trying to determine if we've done this graph correctly, just remember that all negative y values reflect above the x-axis. all of these negative y values. So even these in right in here, these are their values all in between these points. Everything on this line is a value in the graph. So all of those values that were below are reflected above. Now, if you did not include this point, then all of a sudden this graph would just be, you wouldn't come to the x-axis and it would all be up in here, and that's not accurate. So be sure that you include your x-intercept. All right. Now this second graph is a little more difficult to explain. So it's asking us to take the absolute value of x. Well, that seems like it would mean to take all of these original values and just make the x's positive. But that's not exactly the way this is going to work. So I'm going to show you how to do this graph, and then we're going to talk about why we did it. So what we're doing here is everything that is on the right side, or on the positive x, so the positive x portion of this graph would be everything from the y-axis to the right. So everything that was already a positive x, of course, is going to behave like it always did, because a absolute value of a positive value is still the same. So all of these values from here all the way down, those values are going to stay the same. So where are those in our chart? Well, in our chart, that would be anything from our y-intercept on down. So those points are going to remain the same. So I'm going to go ahead and put those in our chart. So I'm going to leave a few spots up there. 0, 3, 2, 0, 4, -3, 8, -3, all stay the same. I'm going to go ahead and plot those. 0, 3, 2, 0, 4, -3, and 8, -3. And I'm going to go ahead and join those. Okay. Now, let me try to explain what's happening on the other side where the x's are negative. What this is telling me, what this notation says, is that before I actually do anything with this x value, if I put a negative x value in there, like in my chart I had a -1 or a -4 or a -6, I'm going to use this -4 for example. Before I actually do anything with that value, I want to take the absolute value of -4. So it's really f of +4. And if it's f of +4, when I put in -4, it actually is acting as if a +4 were being put in there. Then a +4 gives me an output of -3. Now these other values here, I can figure them out from the chart as well, and I'm going to show you those too. They're a little more confusing, but there is an overall way to do this that's not so difficult. But let's go ahead and look at -1. So if I were to put in -1, then it's going to act like +1 did. Well, +1 wasn't anywhere in my chart, but I can look here and see what +1 did, and +1 went up about 1.5. So at -1, it would go up about 1.5. So when I put in a -1, it's about 1.5. When I put in -6, f of the absolute value of -6 would be f of +6. And if I look over here, +6 is right here, goes down to -3. So in the absolute value, -6 would have to act just like +6. -6 would also go down to -3. So the easier way to do this is all of the values that were positive x's on the right side of the graph, the negative x values are going to act exactly the same way. So we're just going to reflect the right side of the graph. By right side, I mean right side from the y-axis to the right, to the left. So really, there's no need in having to do all of this part, which is a little confusing. All you have to do is take the points here. So 2, 0, and the left side would be negative 2, 0. 4, negative 3 would be negative 4, negative 3. 8, negative 3 would be negative 8, negative 3. So the left side of this graph is a reflection of the right. So this is a much, much easier way to make that graph, with the understanding that what's happening is we're actually taking the absolute value of the x before we run it through the function, before we get an output value. So when you see these, you do not have to give me these values. Just know that you want to graph the right side, these points, and then reflect them to the left. Right side of the graph to the left.